So there is a question that needs to be answered, that how can the manufacturing lead time be reduced? Now, there are different possibilities to achieve this goal, that is to reduce the manufacturing lead time. Now, we are going to discuss two methods from operations planning point of view. They have very fancy names, but basically they are very simple approaches. So one of them is operation overlapping. In operation overlapping, the next operation is allowed to begin before the entire lot is completed on the previous operation. This reduces the total manufacturing lead time because the second operation starts before the first operation finishes all the parts in the order. Actually, there are two terms that we will introduce again in the next lecture, and they are the production lot or production batch, and the second is transfer batch. Now, there are two possibilities. One is that you move the complete batch after it has been processed on machine 1 to machine 2. So in that case, the size of the production batch will be equal to the size of the transfer batch. So unless a batch has been completely processed at one workstation, it is not moved to the second or the next workstation. So that results in a lot of waiting for the following workstation or the work center. So in order to reduce that waiting time, we can actually reduce the size of the transfer batch. So that is the basic idea. That, for example, we are having a lot of 100 or the batch size of 100. So one possibility is that we first process 100 units on operation 1 and then move those 100 units to operation 2. So that will be this case. The second possibility is say that we make 20, we make 4 lots of 25 each. And once 25 parts have been processed on operation 1, only then we move them to operation 2, and then the second lot of 25, then the third and fourth. So that reduces the waiting time on operation 2 or workstation 2. So that is the basic idea, that once a certain quantity of production batch has been processed on operation 1, it is moved to operation 2, and the second lot continues to be processed on operation 1, and then it moves to operation 2 once the lot 1 at operation 2 has been completed. So that is the basic idea. So in operation overlapping, the next operation is allowed to begin before the entire lot is completed on the previous operation. This reduces the total manufacturing lead times because the second operation starts before the first operation finishes all the parts in the order. So let's take a simple example to illustrate this idea. An order for 200 bell ringers is processed on work centers 10 and 20. Now, for the sake of simplicity, on the previous slide as well as in this example, we are assuming 2 work centers, but of course we can have. Setup and run times are as follows. It is decided to overlap the lot on the 2 work centers and to split the lot into 2 lots of 75 and 125. So this lot or batch of 200 is split into 2 lots of 75 and 125. So you could say that this is the batch or the production batch, and that has been split into 2 transfer batches. They are of size of 75 and 125. So move time between operations is 30 minutes. Work center 20 cannot be set up until the first lot arrives. Calculate the saving in manufacturing lead time. So let's solve the question before overlapping and then after overlapping. It's so that we can calculate the saving. So the manufacturing lead time before overlapping the 2 batches of 75 and 125 So I hope you remember how we calculated the operation time. So that was equal to setup time plus run time. So at work center 10, that will be equal to setup time of 50 plus run time for 200 will be equal to lot size of 200 into the time required to process one unit. See here that setup time is 50 and run time is 5 per piece or per unit, and for operation B it is 100 minutes, the setup time is 100 minutes and run time is 7 minutes per piece. So that will be equal to 1050 minutes. Now the transit time or the move time between two operations is 30 minutes. Similarly, the processing time or operation time at work center 20 will be equal to setup time plus run time. So setup time for work center 20 is 100 minutes and operation time or the run time is 7 minutes. So that will be equal to 1500. So total manufacturing lead time will be the sum of these. So that will be equal to 1050 plus 30 plus 1500. So that will be equal to 2580 minutes. And we can divide by 50 to convert into hours. So that will be equal to 43. So that is the manufacturing lead time before overlapping. Similarly, the manufacturing lead time after overlapping. So that will be equal to, now we are having two transfer batches of 25 and 125. So first for work center 10 or operation 1, that will be equal to setup time of 50 plus, now we are not having 200 but 75 into 5. So that will be equal to 425 minutes. Now it is important to visualize that once these 75 pieces have been processed on work center 10, they will be moved to work center 20. So we are having a transit time of 30 minutes and now for work center 20, the setup time of 100 plus 200. I will explain why I'm writing 200 here. So you could split them and calculate separately for 75 and 125. So that will result in the same answer. But I will graphically explain it as well. So that will be equal to 1500. Now the total manufacturing lead time will be equal to 425 plus 30 plus 1500. So how much will be that? 455 plus 1500. So that will be 1955. So that will be equal to 32 hours and 35 minutes. And saving in manufacturing lead time is the difference of these two. So that will be equal to the difference of these two. So that is about 10 hours and 25 minutes. Now it is important to visualize these calculations, and they can be better visualized graphically. So we had a changeover time of 50 minutes for work center 10, or you can say operation A. Operation A means work center 10. It has a changeover time of 50. Then we had the first lot of 75, this one. So this took the time equal to 375 minutes. So that is 75 into 5, so that is equal to 325. Now the transit time is 30 minutes, so this time is 30 minutes. And the law 2 requires 200 into, sorry, the law 2 requires at work center 10, 125 into 5. So that is 625 minutes. Now it is important to understand here that this 30 minutes and these 625 minutes are overlapping. So once this lot 1 is being moved to operation B or work center 20, at the same time we are processing the lot 2 at work center 10. So actually these 30 minutes will be consumed during these 625 minutes. Similarly, the setup time for work center 20 is 100 minutes. So this is 100. And first lot will require 75 into 7. So that will be equal to 525 minutes. And the second lot will require 125 into 7. So that will be equal to 875. So the sum of these is 875 plus 525 is 1400 plus this 100, 1500. So this is that 1500 that I directly wrote. So as a summary, we can say that this work center 10 is requiring 50 plus this should be, I think, 375. So 75 into 5 is 375. So that is 50 plus 375 plus 30. So total time required is 455. So this is 455. So this is the time being spent at work center 10. Similarly, at work center 20, the time being spent is 100 plus 525 plus 875. So that is equal to 1500. So 100 plus 525 plus 875. So that total is 1500. So we add them together. So that will be 1955. So this time. Now these 1500 are actually overlapping with this much time that is required by lot 2. So that is why I have written for work center 10, the time to be equal to 50 plus 375 plus the 30. And this time, this much on work center 10 is overlapping with work center 20. So that is why we are not adding that time and we are taking these 1500 minutes for work center 20. So this total turns out to be the sum of these two is 1955. And we had 2580 before overlapping. So difference of the two is the saving in the time. So I hope it is clear. If you have any question, you can ask. So another way to reduce the manufacturing lead time is operation splitting. And again, this is a sort of difficult word for a very simple concept. So operation splitting is a second method of reducing manufacturing lead time. The order is split into two or more lots and run on two or more machines simultaneously. So in a way, the idea is the same, that we split the order or the production lot into two or more lots, and that is run on two or more machines simultaneously. So we are actually adding a machine or a resource in parallel. So same machine or resource is being added in parallel. So that is operation splitting. So same operation is actually being performed on two or more machines. So that is a fancy word, operation splitting, for just the concept of adding one or more machines in parallel. So if the lot is split in two, the runtime component of lead time is effectively cut in half, although an additional setup is incurred. So for example, if you are having a setup time of say 50 minutes and you are making 200 pieces and each one of them requires 7 minutes, just we saw in the previous case. So you add another machine in this case, that is why it is called two machine operation splitting. So you will require a setup time of 50 in both cases for both machines, but the runtime will be cut into half. So that will become 100 into 7 and 100 into 7. So in this case, the manufacturing lead time was 50. In fact, it was 100. So let's take the same value so that it is clear. So that will remain 100 plus 1400. So that will become 1500. So it was 1500 minutes. Now, after operation splitting, now it is 100 plus 100 into 7. So that is 800. So as these 800 minutes, these two are in parallel, so total manufacturing lead time will be 800 minutes. So it has been reduced from 1500 to 800 minutes. So that is the basic idea of operation splitting. So of course, in this case, we are assuming that we do have an idle machine or resource available to be added in parallel to the existing machine or resource. So if it is a cheap resource or it is a manual operation, then it is easy to add it in parallel to the existing process. But otherwise, it is an investment decision whether you should purchase a new machine or equipment or not. So let's solve a very simple example, very similar to the one we saw. An order of 100 of a product is processed on operation A. The setup time is 50 minutes and the run time is 90 minutes per piece. Since this is a rush order, it is to be split into two lots of 50 each and run on two machines in the work center. The machines can be set up simultaneously. Calculate the manufacturing lead time if the 100 units are run on one machine, and the manufacturing lead time when run on two machines simultaneously. So it is very similar to the previous example, this one. So before splitting, the manufacturing lead time will be equal to so that will be equal to setup time of 50 plus run time of 100 into 9. So that will be 950 minutes. And after splitting, so that will be equal to 50 plus 50. We are assuming that it is split into two lots of 50 each. So both will require this time, 50 plus 9 into 50. So that will be 500. But these 500 minutes will be in parallel. So we are not adding them. So the difference of these two will be 450 minutes. So that is the saving in manufacturing lead time.